Hello dear students. In this video, we will start with the second chapter in Science 1, that is work and energy. Now, work can be either physical work or mental work. For example, if you'll see some person working, we'll say कि अरे ये person work कर रहा है, ये उठा के उधर रख रहा है and all. Also, I can say that a boy is studying and he is doing work. So, work can be of two types. That is, it can be mental or physical. So, you can do work mentally also and physically also. And for doing any kind of work, we require energy. If you have to lift a particular object from one place, then also you require energy. If you have to study, you require energy. So, for doing any kind of work, we require energy. In this chapter, that is in physics, we are going to study about work which is a physical work. So let's start and we'll learn about physical work. Now students, observe this picture where you can find work is done. In the first picture, the girl is studying. Well, she is only studying, there is no physical work done. So that means no work is done. In the second picture, the boy is playing with a ball. So here work is done. As he is using some force, he is using some energy, so work is done. Next, the girl is watching TV, no work is done. Next picture, the person is lifting sack of grains. So here work is done. So what we can say is that when the work will be done. So the work is said to be done when a force applied to an object causes displacement of the object. Whenever you apply some force and because of that the object moves from one place to the other place, that is called as work. And that time we will say as the work is done. So that means we can say that work is equal to force multiplied by displacement. And we have already studied this formula that work is equal to force into displacement. That is, whenever work will be done, force and displacement will occur. Now let's look how we can calculate displacement of an object. So in the first figure, that is in figure a girl wants to displace a wooden block from point A to point B. Now, has she used any force? So when she is displacing this particular wooden block from point A to B, so is any force being utilized? Has all the energy she spent been used to produce acceleration in the block? Which forces have been overcome using that energy? So we have to find these things. So here, only the part of the energy that is applied by the girl is used in the acceleration in the block. And also the force of friction has been overcoming using this energy. So when she is displacing this object, so force of friction is also overcoming the energy part. Now in the second picture, we see that a child is pulling a toy cart with the help of a string. And we can see that the direction of force is different from the displacement, as the force is applied by the string but the cart is pulled in the horizontal direction. So actually में क्या हो रहा है, force तो एक angle में apply हो रहा है but cart जो है वो तो straight move हो रहा है. So that means the force applied and the displacement is not same. In the third picture, we see that a large car tows a small car. And here also the direction of force and displacement is different, as the force applied along the string and the car is different. The force applied along the string is in an angle and the car moves in the horizontal line. So in these both cases, the direction of force makes an angle. Here also the direction of force makes an angle and here also the direction of force makes an angle. So let us now calculate the amount of work done if force applied makes an angle. So let's calculate the work done when the force is in angle, that is when the force applied forms an angle. So first of all, we know the formula for work. Work done is always force into displacement. But here we are taking F1 as the force. Now if you will look at the diagram, this is that particular cart that was being pulled by the girl, or you can also consider this as the car that was being towed by the bigger car. And here is the string from where the force is applied. So from here our force is applied. But actually our force should be applied in this direction. So here we have written as F1. And this is the angle which is formed. So this angle we have taken as theta. So here we have taken work is equal to F1 into S. Now we need to find the value of F1 when the angle is formed. So here, now this is geometry, that is trigonometry, and you will be studying about trigonometry in your later maths, that is in your geometry chapters. So first for this you need to understand that cos theta, we have taken here cos theta, that is equal to base upon hypotenuse. This is the base and this is the hypotenuse. Cos theta is equal to base. Now base is F1. So we have written base as F1 upon F. This is our hypotenuse and this we have taken as F. So cos theta is equal to F1 upon F. Now F1 if we will take on this side, so we will get as F is equal F multiplied by cos theta. So this is the value of F1. So here we can put the value of F1 now. So here we can put as work, that is W is equal to F cos theta multiplied by the displacement. So finally what we will get is work is equal to F, that is force multiplied by displacement cos theta. That is work is equal to Fs cos theta. Now theta can be any angle. Theta can be 0 angle, 90 degree or 180 degree. So any value can be there. It depends on which angle that particular string is being pulled. So if theta is 0, that is if it is pulled at 0 degree, so the value of cos 0. Now theta value is 0. So value of cos 0 is 1. Now how to find out these values? You have a particular chart in your trigonometry that this particular value has this, that cos theta is 1, or what is sin theta and so on. So here cos 0 is 1. So that means Fs into cos 0, that is 1, Fs into 1, so our value becomes Fs. So if theta is 0, that means work is equal to force into displacement. That means the angle is 0, so work will be force into displacement. If we will take angle as 90 degree, for example, the string is being pulled in this direction. So what it will be? Now cos 90, theta is 90, so cos 90 is 0. Fs into 0 will be 0. So that means no work is done. Next, if we will take 180 degrees, so cos 180 is minus 1. So work will be equal to minus Fs, that is minus of force into displacement. This is called as positive, negative and zero work done, that we will be studying. So this is how do we calculate if the force is applied in an angle. And now this angle can be any degrees. It can be 90, it can be 100 or whatever. So according to that, we need to take that particular value. 90, it can be 180, 360 or whatever the value is. So we have to remember this, that W is equal to Fs cos theta. And when do we apply Fs cos theta? Whenever work is done and it forms an angle. जब भी angle form होगा, जो भी work हो रहा है, वहाँ पे हम लोग Fs cos theta का value use करेंगे. If the angle is not formed, for example ये string इसी direction में pull हो रहा था, displacement यही direction में हुआ, तो we will not take Fs cos theta. We will only take W is equal to Fs. But here क्योंकि वो string ऊपर pull हो रहा है, that is the reason we are taking W is equal to Fs cos theta. Let's understand positive, negative and zero work. Now work, that is the amount of work done, changes according to the type of work that we are doing. Now it will change as, like for example, walking up and down a staircase, the work done that will be different. When you climb a tree, the work done that will be different. When you stop a car by applying brakes, the work done that is also different. And when you push a vehicle, that is also a different type of work done. So it depends on what type we are doing. What are we doing? Accordingly to that, the work differs. So first we have positive work. Now what is positive work is when the force and the displacement, जब हम force जो applied करेंगे और जो displacement होगा, they are in the same direction. That means when theta is 0. So work done is positive. So here you can see whenever the theta is 0 as it was 1, so our work done is always positive. So whenever force and displacement are in same line, you can say in the same direction, so the work done is positive. Now we have learned what is force, what is displacement and all those things in your first chapter, that was laws of motion. When the force and the displacement are in opposite direction, force कोई और direction में apply हो रहा है and displacement कोई और direction में हो रहा है, that time our theta is 180 and the force is negative. Next is when the applied force does not cause any displacement, or when the force and the displacement is perpendicular to each other. When both are either perpendicular or nothing is happening, no displacement has taken place, that time the work done is 0. So actually the work done depends only on two things, that is force and displacement, as work is what? Work is the product of force and displacement. So that is why if it is theta is 0, that is if the angle is 0, work is positive. If the angle is 180, that is if they are in both opposite direction, it is negative. And when it is 90 or when no displacement occurs, that time the force, the work done is 0. Now here to understand positive, negative and 0 work, we have taken three scenarios. The first one, we have taken a cup and we have tied this cup to a nut here. In the second case, we have taken a cup, we have tied this to a nut and we have kept a scale here. And in the third scenario, we have kept a cup and we have tied two nuts in the both direction, that is both are in opposite direction. Let's talk about the first cup. What do you think? What is happening here? Well, the cup gets pulled as the force of the nut and the displacement of the cup is in same direction. This cup is getting pulled in this direction only, as the force should be applied by this nut and this nut is pulling it down. So that means the force and the displacement are in same direction. In the next picture, we have kept a scale here. So what is happening here? The force is applied by the nut, but this scale is also applying its force in opposite direction. And that is the reason it is not allowing this particular cup to get pulled by this nut. So that means it is getting applied in opposite direction. This particular scale is applying its force in opposite direction and this nut is applying its force in opposite direction. Next, in this case, the cup does not get displayed as two equal forces are working in opposite directions. Now here two nuts of same size are there. This nut is also applying its force. This nut is also applying its force. दोनों का जो force है वो एक दूसरे से cancel हो जाता है and that is the reason this cup doesn't move. So now what do we came to know? That in the first one it was positive force, as the force and the displacement was in same direction. दोनों एक ही direction में था. जो नट था it was pulling this cup in this direction only and the cup का displacement यही direction में होगा. That is why it is called as positive force. Next is second one will be what then? Second one is negative force, as the scale is applying the force in opposite direction and the nut is also pulling the cup in the other direction. So that is why it is negative force. Third one is zero force, as nothing is happening. The force is being cancelled by each other. दोनों जगह से एक ही जैसा force apply हुआ है and that is why it is zero work. So this is called as positive, negative and zero work.